Hi, in this video, we're going to talk about how to divide rational expressions. So the steps we're going to use are, number one, we're going to rewrite it as a multiplication problem. Then we're going to factor all numerators and denominators. Then you can cancel out any common factors and multiply what is left over. Now, one of the key parts here is understanding how to rewrite it as a multiplication problem in the first place. So let's say you have the division problem a over b divided by c over d. What we're going to do is called keep, change, flip. You're going to keep the first fraction, change to multiplication, and flip the second fraction. So you'll notice that when I rewrite this as a multiplication problem, I've kept a over b, I've changed to multiply, and I have flipped c over d, so now it is d over c. From there, I can treat it like a traditional multiplication problem. Let's take a look at an example. Let's say I have 9 over 20 divided by 12 over 25. Well, I'm going to start by rewriting this as a multiplication problem. I will keep 9 over 20, change to times, and then flip my second fraction so that it's 25 over 12. Now I'm going to factor this completely into its prime components. 9 becomes 3 times 3, 20 becomes 2 times 2 times 5, 25 is 5 times 5, and 12 is 2 times 2 times 3. Now that I have that set up, I can cancel all common factors. So you can see I have a 3 in the top and bottom and a 5 in the top and bottom. Once I get rid of those, my first fraction becomes 3 over 4, and my second fraction becomes 5 over 4. I can multiply those together to get 15 over 16. Not too bad, right? Well, let's try another one. I have 10 over 3x divided by 4 over 5x. I'm going to rewrite this as a multiplication problem by changing to multiplication in the middle and flipping the second fraction. So it's now 10 over 3x times 5x over 4. When I factor this completely, the 10 becomes 2 times 5, and the 4 becomes 2 times 2. That makes it easy to see that my common factors are 2 and x. So I cancel out the 2 on the top and bottom and the x on the top and bottom, and I end up with 5 over 3 times 5 over 2. I can multiply across now. 5 times 5 is 25, and 3 times 2 is 6. So my answer is 25 over 6. Now, what if I make it a little more complicated and I put a ton of variables in? Well, don't worry, it's not too bad. We're still going to rewrite it as a multiplication problem by flipping that second fraction upside down. Then we're going to factor. Now, x squared minus 4 can factor into x minus 2 times x plus 2. And 4x plus 12, you can pull 4 out of both terms, so you have 4 times x plus 3. Now, I can see that my common factors are x plus 3 and x minus 2. Once I cancel those out, I'm going to have 1 over x plus 2 as my first fraction, and 1 over 4 as my second fraction. When I multiply across, I'm now going to get 1 over 4 times x plus 2. And that is how you divide rational expressions.